Ever feel like you're drowning in digital files? Pictures, videos, that novel you're working on, it all adds up.
It does.
Now imagine that problem,
Yeah.
but instead of your laptop,
Right.
it's millions of files,
Right.
each bigger than a movie.
Wow.
And the fate of Google search depends on accessing them instantly.
That's a good way to put it, actually.
So that's the challenge that Google tackled
Yeah.
with the Google File System.
Or GFS, as we tend to call it.
GFS.
Yeah.
What's fascinating is how they flipped the script on what a file system could be.
Especially back in the early 2000s.
We're going deep on GFS today, pulling from the original research paper.
Oh, very nice.
Don't worry, we'll translate the tech speak into something that makes sense, even if you're not a coding whiz.
I'll try to, at least.
Yeah. Think of this deep dive as uncovering the engineering choices that make internet giants possible.
It really is amazing what they accomplish.
Right, so GFS,
Okay.
what's the headline here? What makes it so different from how, say, my computer organizes files?
Well, in a nutshell,
Yeah.
GFS embraces the reality that things break.
Okay.
Hard drives fail, networks hiccup, especially when you're talking the scale Google operates at.
Makes sense.
So instead of trying to prevent every error,
Right.
they designed a system that expects them
Okay.
and recovers automatically.
That's kind of genius, actually.
It is, yeah.
Like plan for the mess instead of pretending it won't happen.
Exactly. And they also knew they were dealing with huge G files, way bigger than most systems are built for.
Right.
And not just storing them,
Right.
but constantly accessing and analyzing them.
So not just a giant digital library,
Yeah.
but one where everyone wants the same book at once.
And they want specific chapters, fast.
Okay.
This led to some unconventional choices, starting with how they break down these massive files.
Okay, let's unpack that.
Okay.
This is where those chunks come in, right?
Yes. Instead of one big file, GFS divides everything into 64 megabit chunks.
Okay.
64 megabytes.
64 megabytes is.
Yeah.
I'm picturing a floppy disk from my childhood just to grasp that size.
Right.
So why so big?
Well, think about it. Larger chunks mean fewer pieces for the system to keep track of.
Oh, okay.
Imagine a library where every paragraph was a separate document.
Oh, gosh.
Chaos.
Yeah.
GFS simplifies by grouping things intelligently.
So less for the system to juggle, which means, what, faster access?
Right.
Less chance of losing a tiny piece.
You got it. Fewer, larger chunks reduce the workload on the master server.
Okay.
This is like the head librarian, the one who knows where everything lives.
Okay, head librarian has a map to the chunks, but what about the actual data?
Yeah.
That's where the chunk servers come in, if I remember correctly.
Precisely. Each chunk server stores a bunch of these 64 MB blocks.
Okay.
And here's where the genius of redundancy comes in. Each chunk is replicated,
Okay.
usually 3 times on different chunk servers.
Wait, so if one chunk server has a meltdown,
Yeah,
there are like backup copies ready to go.
exactly.
That's seriously smart.
It is.
But what about knowing a chunk has gone bad?
Right.
Hard drives are fickle beasts.
That's where checksums come into play.
It's a fancy way of saying each data chunk gets a unique digital fingerprint.
Like a digital signature that proves it's the real deal, not some corrupted mess.
Exactly. Every time a chunk is written, its checksum is calculated and stored.
Okay.
Later, when that data is accessed,
Right.
the checksum is recalculated and compared to the original.
Makes sense.
If they match,
Yeah.
you're good to go.
And if they don't match, that's when we find out if this system is as clever as we're hoping.
Right. That's when GFS swings into action.
Okay.
The mismatched checksum, it instantly signals a problem.
Right.
Maybe a minor error during writing.
Yep.
Maybe a hard drive on the fritz.
Right.
Either way, GFS knows exactly which chunk is affected
Okay.
and grabs one of those healthy replicas we talked about.
So it's self-healing. Like it knew.
Right.
I'm starting to think my personal computer could learn a thing or two from Google's playbook.
Yeah, I think we all could.
But this whole system hinges on that master server, right?
It does, yeah.
What happens if that goes down?
Yeah.
Talk about a single point of failure.
Ah, but they thought of that too. Remember how GFS assumes failures are inevitable?
Right.
That applies to the master server as well.
Okay.
Enter the shadow master.
Okay, now that sounds like something out of a spy thriller.
It does, doesn't it? It's
Yeah.
not as ominous as it sounds.
Okay.
The shadow master is a constantly updated backup.
But
It's like having an understudy
Right.
who knows all the lines and blocking, ready to step in if the lead actor gets sick.
So the master server has a constantly updated twin. Just in case.
Right.
That's reassuring, given how much depends on it.
It is, yeah.
But walk me through this. How does this shadow know what the master is doing all the time?
It's all about meticulous record keeping.
Yeah.
The master server keeps a detailed log of every single operation.
Oh.
The shadow master reads this log constantly, staying in sync.
So they're like in perfect sync.
Exactly.
Okay.
If the master goes offline, the shadow is ready to take over instantly,
Wow.
minimizing any disruption.
Okay, color me impressed. They really did think of everything.
They really did.
But this whole chunk system, these checksums, the shadow master,
Right.
it's all about making sure data is stored safely and accessibly, right?
Yeah, that's the core of it.
But what about actually using that data?
Right.
Google's not just hoarding information.
Right.
They're constantly analyzing it, searching it, doing all sorts of things with it.
Yeah, absolutely.
How does GFS handle that kind of workload without becoming a bottleneck?
That's where things get even more interesting.
Okay.
Remember how we talked about GFS being designed for huge GE files?
Right.
And lots of sequential reading?
Right. Okay.
It turns out that pattern is perfect for Google's workloads.
Okay.
Think about massive data sets being analyzed,
Right.
or those logs we mentioned earlier.
Right. More like reading a book than constantly scribbling notes in the margins.
Exactly.
Yeah.
And GFS is optimized for that kind of access,
Okay.
but they still have to figure out how to handle multiple clients,
Right.
applications that need to access the data all at the same time.
Okay.
Imagine hundreds of requests hitting the system simultaneously,
Right.
all wanting different parts of these massive files.
Yeah, that sounds like a recipe for chaos, or at least a very slow internet.
It could be,
Yeah.
which is why they had to come up with some clever solutions
Yeah.
to keep things running smoothly.
How do they keep things from grinding to a halt?
This is where those 64 MB beat chunks come in handy again.
Okay.
By dividing the data into these larger pieces,
Right.
they reduce the need for constant communication with the master server.
Okay.
Clients can grab a chunk and work with it for a while without constantly asking, okay, where's the next bit?
Makes sense. Like getting a whole chapter downloaded at once instead of one page at a time.
You got it.
Okay.
It's all about reducing those bottlenecks.
But what about when multiple clients need to access the same chunk simultaneously?
Right.
Isn't that a recipe for conflict?
That's where GFS gets really clever with its concurrency control.
Okay. Remember those replicas we talked about?
Yeah.
Well, they're not just for backup.
Okay.
When a client wants to work with a chunk,
Yeah.
the master server designates one of those replicas as the primary.
So there's like a designated writer for each chunk.
Yeah, you could think of it that way,
Okay.
to prevent everyone from scribbling over each other.
You got it.
The primary replica gets to decide the order of all operations on that chunk.
Okay.
It's like having a single air traffic controller
Right.
directing all the planes,
Right.
ensuring they land in the right order,
Right.
even if they're coming from different airports.
Okay, that's a seriously elegant solution.
It is.
So GFS is built for speed.
Yeah,
It's built for reliability.
right.
And it can even handle a crowd.
It can.
But we've been talking concepts this whole time. We have.
What about some real-world numbers? Just how fast are we talking? Can GFS download every cat video on the internet in under a minute, asking for a friend?
While I can't speak to the specific feline video download speeds,
Right.
I can tell you GFS is designed to handle massive amounts of data with incredible efficiency.
Okay.
Think terabytes of data being processed every second.
Okay, hold on. Terabytes.
Terabytes.
That's like 1,000 gigabytes per second, right?
That's a lot of data.
My brain's having trouble even picturing that much information.
It is a staggering amount of data.
Yeah.
But it's important to remember that GFS was designed for Google's specific needs.
Right.
They were dealing with challenges no one had really tackled before.
Right.
And they came up with this groundbreaking system to meet those challenges head on.
And they documented it all in that research paper we keep mentioning.
They did.
I have to say, what initially seemed like dry technical jargon
Yeah.
is now sparking a whole new appreciation for the invisible architecture that makes the internet possible.
Exactly. We often take for granted the complex systems that work tirelessly behind the scenes
Right.
to deliver us our search results, our streaming videos, our social media feeds.
It's amazing.
GFS is a perfect example of that invisible complexity.
Right.
And understanding it gives us a glimpse into the incredible engineering feats that underpin our digital world.
It also makes you realize that even deleting files is a bigger deal than you might think,
It is.
especially when we're talking about this scale.
Ah, yes.
Yeah.
Deletion.
Right.
GFS takes a rather unique approach to that as well.
Okay.
They call it lazy deletion.
Lazy deletion.
Lazy deletion.
Does it involve comfy chairs and procrastination?
Mm.
Because I can get behind that.
Not quite, but I appreciate the enthusiasm. You see, when you delete a file in a traditional system,
Yeah.
it's usually gone for good.
Right.
But with GFS, things are a bit different.
To tell.
Instead of permanently deleting files right away,
Right.
GFS marks them as hidden, sets them aside. It's like
Okay.
moving something to your computer's recycle bin.
Right.
It's still there for a while just in case you need it back.
Right. Okay.
But eventually it gets permanently deleted.
So it's like a grace period for data.
You could say that, yeah.
Why even bother, though?
Mm.
Doesn't that just create more work in the long run?
That's the beauty of it.
Okay.
This lazy approach actually simplifies things. Immediate deletion in a system this vast, I mean, it'd be incredibly complex
Right.
and prone to errors.
Cool.
So by delaying it,
Right.
GFS reduces the strain on the master server,
Okay.
making the entire system more robust.
So even deleting files strategically is part of what makes GFS so efficient.
Exactly.
It's all connected.
Every design choice,
Yeah.
from those large chunk sizes
Yeah.
to this unusual deletion method,
Right.
is carefully considered to optimize for speed, reliability, and scale.
It's pretty mind-boggling when you think about it.
It is, yeah.
This paper we've been dissecting,
Yeah.
it's not just about a file system.
No, it's not.
It's a window into a whole different way of thinking about data.
It really is.
What's remarkable is how prescient it was
Yeah.
back in the early 2000s.
Early 2000s, yeah.
They were already grappling with data challenges that most of the world hadn't even encountered yet.
That's right.
And the solutions they came up with, like prioritizing flexibility
Right.
and building for failure,
Yeah.
have become fundamental principles for modern data centers.
Absolutely. And you can see their influence everywhere.
It makes you wonder what the limits even are.
Mm.
If they were already achieving this back then,
Yeah.
what's possible now?
That's the question, isn't it?
It's exciting
It is, yeah.
and maybe a little bit intimidating.
A little bit, yeah.
All at once?
But here's the thing to remember.
Okay.
The core concepts behind GFS,
Right.
the elegance of its design, it all boils down to solving problems.
Right.
And that's something we can all relate to,
Yeah.
whether we're organizing files on our laptops or building the next generation of data centers.
That's a really good point.
It's easy to get caught up in the scale of it all.
Right.
And forget that the fundamental challenges of managing information are universal.
Exactly. And understanding how a system like GFS tackles those challenges, it can inspire us to think differently
Absolutely.
about our own approaches to be more deliberate, more strategic,
Right.
and how we handle even our own personal data.
It's a good reminder for all of us.
So maybe this deep dive wasn't just about Google's groundbreaking file system. Maybe it was a masterclass in creative problem solving,
I like that.
with lessons that apply far beyond the realm of massive data centers.
Well said.
This has been an incredible deep dive.
It has.
Thanks for joining me in exploring the fascinating world of GFS.
My pleasure.
I think we both learned a lot more than we expected.
Always do.
And to our listeners,
Yes,
we've only just scratched the surface here.
that's true.
If this peek into Google's world has sparked your curiosity,
As it should.
keep digging.
Yeah,
How has GFS evolved since that original research paper?
good question.
What new challenges are these massive systems facing today? The answers are out there waiting to be discovered.
They are out there.
Happy exploring.